Welcome to Cooking with Chemistry with Julia Childs. Today we are doing a chemistry cooking show and preparing two items. Neither have never been seen before like this. The first item is tea and the second item is shrimp. The purpose of preparing the tea is to do a cost comparison between heating water using a microwave and heating water on a propane stove in a pot. The purpose of preparing the shrimp is to study three chemistry concepts. The first is to determine whether or not the temperature of boiling water increases by adding salt as the recipe calls for. The second is to determine if the temperature of the boiling water is increased by putting a lid over the top of it and then using a thermometer to see if indeed the temperature increases with and without the lid. The third chemistry concept is to look at these funny little crustaceans, and we've all seen these cooked and they turn pink. So we are going to examine why they might do that. Not experimentally, but by research. The concepts and textbook activities that I will address include Activity 2, Heat Transfer, Activity 3, Heating Curve of Water, and Activity 4, the measurement of energy used to heat water. Activity 7 is also covered by looking at denaturing of proteins. And Activity 8 is studied by looking at changes of air pressure. Materials needed to do this include, of course, smelly little shrimp, a timer, a meat thermometer, a measuring cup. Milliliters are handy, but not necessary since I know the conversions between milliliters and cup. A spoon with holes in it to extract my shrimp from the boiling water. A second pot to cook my shrimp and a corresponding lid to fit on top of it. Now to begin, I'm going to have a race. I'm going to turn on my timer and my stove and time how long it takes to heat up 1 cup of water to boiling. This is conducting the experiment on the tea, of course. 1, 2, 3, on my start, go! At the same time, I can go ahead and add the water in the measuring cup, exactly 1 cup, 246 milliliters, in the microwave for 2 minutes. My boiling water for my tea is not quite as warm. Little accident there. My propane stove almost blew up in my face. Not good, not good. Start my timing over. Okay. Kind of a disadvantage of using propane with small explosions in the kitchen, you know. Okay, we're there. Turn off the oven, your stove, sorry. Timer, whoop. There we go. Did it. Okay. Record my results. 1 minute and 40 seconds to heat the water to 150 degrees Fahrenheit. I'll do the conversions to Celsius in a few minutes. Okay, my water is boiling. I've just taken the temperature and it's 180 degrees Fahrenheit. 180 degrees Fahrenheit, no lid, no lid. Just plain ordinary boiling water. Whoops, temperature's going up a little bit. 180 degrees Fahrenheit still. Okay, going to do is add the salt as instructed by the recipe. About 1 gram of salt. We'll let that mix in there for just a minute. And we'll measure the temperature to see if it's increased at all. And we are at 180 degrees Fahrenheit. Once again, 180 degrees Fahrenheit. Okay. So now what I'm going to do is cover it with a lid, let it build up some pressure, and quickly take the temperature to see if it's actually increased beyond the 180 degrees Fahrenheit. Here we go. Now remember, steam burns are very, very painful, so watch out. Here we go. 180, 190, 190, 198. Whoa. 199. I think we can call that 200 degrees Fahrenheit. Definitely a change. Let's see how it is without the pressure. Ouch. It's hot. 180, 178, 182. Stupid thermometer, not very good one. I also tested my thermometer to make sure that the temperature probe actually was here by running hot water on it versus further up on the thermometer stem, because the heat from the steam condensing on this part of the thermometer might give me erroneous results, but I'm feeling pretty confident. So now, with the boiling water, I'm going to add my shrimp. Here we go, adding the shrimp.
Little.
One at a time. One at a time. One at a time. One at a time. One more. One more. We'll call that good for now. Okay, give them a little stir. Cover it up. Let me ask my assistants, how long should I cook these stupid little fishies? 1 minute? 2 minutes? 2 minutes. Thank you, assistants. Okay. And now the shrimp are done. So if we take a look at this little guy here, we can see that it is a nice, bright, pink, healthy-looking color compared to the raw shrimp, which is kind of a dull, metallic green. Now, I've done some research, and it turns out that this pinkish color has been there all the time. It never was created chemically or any other way. The reason we see the pink now is because the pink molecules, the molecules that make the shrimp pink, are wrapped in a protein. And by boiling this little guy, I have denatured that protein. I have straightened out that long string of amino acids, uncovering the beautiful pink color inside. But this color was not created. The protein that wraps around the color was denatured, straightened out, exposing this wonderful color. That, and along with my 2 other conclusions, I can tell you right now, is that I learned that it is 85% cheaper than heating a cup of water in a microwave is 85% 50% cheaper than heating water on a stove, although the stove was actually faster than 2 minutes. I also learned that salt didn't increase the temperature of my boiling water according to my instruments. Further research shows that I would need about 240 grams of salt for each liter of water to increase the boiling temperature 2 degrees Celsius. I did show that using a lid to cover the boiling water increases the temperature about 10 to 15 degrees Fahrenheit. In summary, everyone, put lids on your pots to boil your water to save energy and prepare your tea using a microwave. For all the data and calculations and much more discussion, please read my final report. Thank you very much.